Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, I have 5 Sharp PC-1211s, and a few of them are, the Radio Shack PC-1, but they're the same thing. Anyhow, I've got 5 of them that I need to take a look at, and I'm hoping to fix at least 4 of them using one for parts. And I got out the document camera that I converted into a surface mount soldering camera so we can get a better look at things and look at the circuit boards for problems and things like that. So without further ado, let's get started. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. Alright, here we have number 1, a Sharp PC-1211. It's not in bad shape on the exterior. I put a new LCD in this last fall and did some other miscellaneous work, and it worked fine for a while and then quit. This belongs to a friend of mine, and I was looking for a parts machine to get his going again. It was missing things like these 2 metal brackets in here, so for fun I made these by hand, just soldering some brass together, drilling some holes in it, things like that. I also put a silicone diode in the positive lead here, which drops the voltage enough that you can use 1.5 volt alkaline cells rather than the 1.35 volt hearing aid cells. So we'll make sure this is doing the same thing it was months ago. And well, phooey. This one was missing a bunch of screws and some other things too. With this document camera, I have a large monitor up in the corner that I look at, but I've got to have my regular glasses on for that. If I want to look at the thing directly, then I need my other glasses. What a pain in the butt. Okay, gosh. And the beeper stuck on. So, I gotta switch glasses again. So you can see it actually works. Except that this whole middle block is wrong. And it did work fine before. I was just waiting to get in some screws I had ordered to put it all back together, and it quit. This is the second CPU. The CPU 1 is under the speaker and mod board here. CPU 2 sends signals to the 3 LCD drivers, which are on this bottom board, 1, 2, 3. And they control 1, 2, 3 or 1, 2, 3. Anyhow, this is the second one, and it is outputting all solid blocks, which is rather weird. So it could be something weird that CPU 2 is only messing up for the center LCD driver, chip select or something. I don't know. It could be the center LCD driver. And I've checked the continuity of all the cables here, etc. So that was a weird one, but I'm glad it happened before I sent it back to him rather than afterwards. And yes, the display's not quite in there right. I didn't worry about that since it still had a problem. Okay, this is unit 1 that we just looked at. Notice that It has regular through-hole parts here. It's got this plastic over the speaker because there's actually a bodged circuit board here, and which is what these wires are for. It fixes some sort of RAM timing issue. Unit number 2, we've got surface mount parts down here on this board. It does not have the bodge board in here. This one I put a new LCD in quite a while ago, and it's scrambled and doesn't quite work. I did not do the diode mod on the positive lead, so I'm using some 1.35 volt zinc air hearing aid batteries. The original ones were mercury batteries. This one didn't beep. And you see it looks fine. The correct enunciators come up. I'll reset it. Everything comes on like it should. Sometimes the keyboard seems to work and other times it doesn't. Now it's not doing anything. So, you know, I've looked at this. I looked at it to see if I scratched a trace or something, but I didn't see anything. This design has 2 4-bit microprocessors or microcontrollers. They have their own ROM built into them. Processor 1 is here. It reads the keyboard. It reads the program from the RAM. It does something or other with the program, sends it to processor 2, which runs the program and displays stuff on the screen. I believe processor 1 also, I don't know, I thought it does the speaker. I'm not quite sure about that though. Anyhow, so this one's close and the display looks good. It just doesn't do anything. And sometimes, so you normally get that line like that when you reset one of these machines, but this one doesn't go away. So it's like it doesn't quite reset correctly sometimes. Sometimes the keyboard will seem to work. So that's that. I have no idea what's wrong with this one. Okay, here we are. Unit number 3. This is a TRS-80 branded. Originally it was just the Pocket Computer, and then once they came out with the Pocket Computer 2, this became known as the Pocket Computer 1. As you can see, the display is just starting to go, or just starting to turn black. This one has not had the diode mod. It's kind of a middle-of-the-road model. It has surface mount diodes and such here, but it doesn't have the bodge board. It does have a few bodge wires though. So we'll do that. And press reset. And you can see the display's not quite right. It does sort of work. I'm in 2 minds about if I should leave this display in or not. Let me know what you think. I'm inclined to leave it in here for a while, although it does kind of make it less than readable. It's hard to tell on camera, but in person, when you're reading it more at this angle, you can see more of these enunciators that aren't supposed to be on camera. You're at a different angle, so you only, and actually shift shouldn't be on either. Yeah, see how it darkens. So I don't know, I might go ahead and put an LCD in it. I've already shown that on camera, so I won't do it here, but it's another reference point, slightly different variation in the design than the other 2 that we've just seen. Okay, unit number 4. It's rather grungy looking, and it has this interesting MMS alignment computer. This is part of some sort of alignment system. I'm not sure for what or how it was used, because the only I/O is the cassette port. So maybe they bodged in a serial connection. It does look like there's been some soldering on this, but that just may have been the hand soldering when they put the connector in. You can see this is another later unit because it has the surface mount diodes and resistors in there. No bodge board, no blue and yellow wires, and it has not had the diode mod done. Now somebody sent this to me, which is really nice of them. I have an interest in the early pocket computers that were sold for single purpose. And this one is missing the little contact that was in there. So I have to kind of cheat and shove the wire in there like that. Okay. And let's reset it. It looks like it's ancient. Name that series. Okay. Now you can see everything kind of came on right, but we've got some extra characters right here. And we have extra stuff that came on the top here that shouldn't be on. And to me, this looks like a misalignment of the LCD slightly. So there's a few things misaligned and causing that problem, so we'll see. I'm in two minds about cleaning up the grunge. You know, it's part of the original patina, but it makes it kind of not nice to touch and very hard to see. So I'm hoping this isn't too difficult to fix. You kind of look at it at this angle, you can see it's slightly darker at the top of these segments, which is kind of interesting. So we will see what we find. This is unit number 5. I bought this from Japan through Zen Market. As you can see, the LCD is shot. It's very dirty. Case is kind of beat up. It does have the cover here, amazingly. And this is one of the later units with the surface mount parts on the board. Now, I already tried putting batteries in this, and it doesn't power on at all. On all of the 3 board versions that I've been able to identify, this red wire here and black wire here is the battery voltage, and it goes through, 4 batteries. Then you'll wind up with about, because of the diode drop, you'll wind up with about 4.8 to 5 volts across here. This does not have that. And after looking at this, there's a little bit of green corrosion here. And if you look down in that hole right there, which you can't see, but it's where the negative part of this battery contact comes up and it presses on the board here. And that looks like it's corroded. So even though this is a junker that I bought for parts, I'm wondering, even though this case is pretty shot, we might be able to clean up this corrosion and take this board set out and put in number 1, which is my friend's. That was acting wonky, and get that working, and then use that one for parts. That way we're reducing the number of boards that we have to solder on, because these old phenolic boards are not very nice to rework. It's very easy to ruin them. So we'll see how that goes. I actually think we'll start with number 5 here, and we'll try to clean this up, and we'll see what happens. I think what I might do first is solder on a couple of wires here. And on this board revision, they also get down to right here. But you can solder red and black wire on here, feed it with the bench power supply, and power it without messing with the batteries. So we can take the board stack out, or we can power with batteries first to see if it looks like it's working. And then we can take the board stack out and look at that contact. We will start on this one first. If the board works, we'll transplant it into my friend's case and make one good unit out of the 2. Okay. Slobbered a couple wires on there, and I'm just going to rotate it around upside down so our wires are actually in the right way. You can probably hear the bench power supply in the background. And we'll turn that on. Okay, it's not showing it's drawing any current, and I think we saw some. You can see this area of the display. I'll turn it off. Okay, it is doing something. Let's press reset. Okay. What happens if we press a button? Oh yeah. Clear. 55 times 55. Enter. 3025. So this grungy old beat up thing actually works. It has a corroded battery contact. So we'll go ahead and take this apart, see if we can clean up that contact and transfer it into the other case. Okay, now to pull apart number 5 to see if the problem is corrosion right here. Let's pull this connector cover off. Get him out of the way. Now there are 2 screws here that holds this top board down to these metal brackets. There are 6 screws here that hold this side of the bottom board down. And 2 more screws that hold the bottom down, and this which holds the beeper down. And you also have to pull these battery connectors up that are soldered on. So I'm going to do these 6 first. Those are not wanting to come out. I'm using the JIS screwdriver here, which is the Japanese version of Phillips. It does not cam out like a Phillips screwdriver does, and it fits these Japanese screws much better. Okay, now take the speaker loose. Lift him up out of the way. Oh, there's another screw right there too. I'll take the top board loose. And then we'll do these 3 screws. Okay, now on this guy, just the positive lead. You can very carefully pull him straight out. And on this one, this is not actually the negative here. I'll pop the power supply wiring diagram up here. This is the tap between the middle of these 4 sets of batteries for the 2 clamping diodes, which is a kind of a strange arrangement. Okay, so kind of rotate this up, and you have to tilt the whole thing like this and pull it out. Kind of like that. Okay. Oh, and don't. That's all the screws that were stuck in the holes there, and one just hit the ground. Okay, well that was better than all of them hitting the ground. Well, here is that contact in question, and it is indeed corroded, and this one's similar looking, but it doesn't really connect to anything, so we'll just see what dirty part we can get off there with alcohol. Now I'm going to try a clean pencil eraser. And again with the alcohol. Well, it has some spots corroded through. And if we look at those contacts on the computer itself, that's right there. Give those the same treatment. So the button cells do leak, but they're certainly not as bad as some other types of batteries. Okay. And on the rest of the board here, that looks pretty good. And this is the original LCD. And it looks like it has some problems starting in the middle there, but it's not too bad. Right now, what I'm interested in is if we can get this whole unit working so we know what parts we have. Okay, I'll put this back together and then we'll try it out. So it's back together now. We need to put in the fourth battery. And that is still not making, yeah. Try to reset it here. And you can just see there, we are getting some characters. So, and they went away. So probably what we'll need to do, since the point where those, or the area where the points from that bent up metal piece contact that gold-plated pad, that's kind of corroded, we'll put some solder on there. And this is fully working. The parts machine, the junker, is fully working, but it needs a new LCD. So we can take the guts out of this and put into a better case to replace one of the bad boards if we need to. Okay, now we're on to Unit 4. We went from 5 to 4. This is the alignment computer. It's had a new LCD put in it by the person I got it from, but it had some stray pixels on, which I'm guessing might just be an alignment of the LCD. I swapped over the power leads so we can power it up outside the case, and I will take this out of the case now, then we'll have a look at it. So you can probably hear the bench power supply there. I'm going to power it up here just to refresh our memory of what it's doing. So it looks okay, but we've got a couple extra dots and some ghosting on some other characters. And if we look at this edge here, you can see how the board's kind of puckered in between each one of these stakes. I wonder if these are down a little too tight. There's a few of these in here that look a little loose on this side. So I'm going to pull the LCD off and check its alignment. And we'll try to put it back on and see what happens. So to pull the LCD off this, first note that the hole in the frame is on the left side. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 stakes, and you want to be careful not to scratch the traces. It's easy to do. So I like just getting them started with a screwdriver. Trying to use another finger to keep the screwdriver from going skating if I lose contact. Okay, and then we can take our mini pliers, straighten these guys up. This one I didn't get started quite enough. Just got to get it up enough to where you can get a hold of it with the pliers and straighten it. Like so. Oops, got one more. Okay. Now we can use a spudger to kind of get in there and get the zebra strips wanting to release. Maybe push down on the... There we go. Okay, so here's our board. That looks good. Looking at where the tabs are on the other side, it doesn't look like any traces are scraped. That's easy to do. I've done it. We have a bit of waviness right here in this zebra strip. There's some dirt inside here. So I'm going to pop this apart, clean the LCD and the zebra strips with some alcohol, and then we'll try putting it back together and see if it makes any difference. I'll link to a video below where I've done a more extensive shot of taking one of these apart and cleaning it up and that type of thing, where I'm swapping the whole LCD. Well, I got our little guy here put back together after trying to realign the LCD, and you see I've got the plastic in here wrong. But it didn't make any difference. All the same segments that aren't supposed to be on are, and it does weird things. So then I got to wondering, well, did those things which were on what shouldn't be, oh, phooey, guess what? Some keys fell out of it. Oh yeah, the keyboard's completely screwed up on this one. I didn't put enough screws back in it. And, okay, looking at the schematic, this is the digit that has the dots that are on that shouldn't be. And if we follow those up, they go to this line, which goes to display driver chip 1. And coincidentally, all of the annunciators also go to display driver chip 1. So does that mean the display driver is bad? You know, we've got address and data signals here, a chip select and things like that. Well, display driver chip 1, 80 bytes of the video RAM that's not used in there is used for the input buffer. So it seems very unlikely that it just happens to work great for everything except for the annunciators and a few dots here. So my suspicion is this display driver chip is bad. And that got me thinking about several months ago. I was talking with a friend, and he was talking about how these LCD driver chips were kind of a hybrid analog digital sort of thing. And they had a lot of problems figuring out the manufacturing process for that. So they tend to fail a lot. We see this on the Model 100 LCDs. Those chips sometimes fail, especially now that they're 30, 40 years old. So I think this is the number 4 unit. So I think on this number 4 unit, I will try to swap in another one driver from another board. The number 5, if you recall, that's this guy. That's the parts machine, which works except for the case is rough and the LCD's bad. And then we've got number 1, which the case is halfway decent on. I'd put a new LCD in it, and then the LCD driver 2 went all black. And other than that, it seems to work. And the LCD driver 2 also has the I think A through K fixed memories in it, and all those work fine. So again, it doesn't seem like it's a problem getting data to the chip, but perhaps getting data out. So I'm going to take the board from number 5, which is a later version, and put into number 1 and swap the new LCD over, and that should get a nice working unit for my friend. And then I can take the display driver chip from number 1 and put in number 4. and hopefully that'll get that one working too. But we shall see. So I think the first thing I'll do is swap the 5 board into the 1 case along with these brackets and things like that. So we've got a start on the swap of the guts of Unit 5 into Unit 1. Pulled the Unit 1 board out, took out the new LCD that was put in there. Taking the brackets from Unit 5, I had made these by hand. Rather than using a CNC machine or anything like that, I just did it all by hand. Some sheet brass. I did bend a little jog in it and then solder 2 pieces on top. They didn't come out great, but they were functional. So it's just kind of an exercise to see what could be done. So now I need to extract the board from here, and remember we need to solder up that pad right here where that was corroded a little bit. And then we'll put this onto the LCD, and then we'll slide the whole thing into this case, which is the number 1 case with these brackets. So let's get that started. One thing I like to do when working on swapping LCDs is use a sheet of paper, white paper, so you can see all the little crumbs and specks of dirt. Keep you from getting it trapped under the LCD or something like that. And all the screws should be out of this guy. We can pull him out. We'll set case number 5 aside. One other thing I want to do while I'm thinking about it is swap the positive lead from 1 to 5. The one on Unit 1 has the diode in series with it already. Okay, now we need to swap the LCD over. Again, I'll just do that off camera. You saw me pull the LCD off unit number 4, and I'll link to the video where I do a complete video about swapping in a new LCD that's got a lot more detail. Alright, I got the board out of number 5, and we need to add some solder to this corroded pad. So the first thing I'll do is very lightly scratch it with the fiberglass brush. Just remove any oxidation and give us a good layer to solder to. Wipe that down with some alcohol. And just a teeny tiny bit of flux. Don't know how well that's going to do actually. So I'll keep cleaning up this solder patch I'm putting on here, and then swap the new LCD in. Well, the patching of this pad worked a little differently than I thought it might. I took this section out of the sprue on this paste circuit through-hole kit and cut it to fit there, since there was already solder on there, and this stuff is tin-plated copper. It soldered right down there. Now I have a good solid connection to the circuit and something for that to press against. I've got the new LCD laid out here like this, and the hole is to the left, which is here. So we'll get this installed on here. Actually, I install this on here like this. It's a lot easier. You don't wind up having stuff trying to fall out of the frame that way. Anyhow, I'll get that done, and then we'll slip it in the number 1 case and see how it works. Okay, we've got board set number 5 with the LCD from number 1 and the number 1 case. We also swapped over the number 1 positive lead, and we've used the screws from number 5 since number 1 had so many missing. And since we've got that extra diode in there now, I can put in 1.5 volt alkaline batteries and we'll see if it works. Oh, we've got way too much contrast. Okay. Yep. You can see that there. It looks like it's all solid blocks. There's just way too much contrast. So what we need to do, I forgot about that. This board has not had this pot adjusted. Basically, my air conditioning's turning on here in the background. Basically, the new LCD has higher contrast, and most of these pots you can't adjust, but if you just bend up the wiper, it is the perfect setting. So I'll do that and we'll try it again. Okay, I've tweaked the contrast pot. I turn it on. It now resets properly. We have a beautiful LCD. Don't have any dirty spots in there. 55 times 55, enter, 3025, shift and unseater works, all that type of stuff. So can't complain about that. Change the mode. Excellent. So I'll do some more testing on this later. For now, we've got number 1 working. We took the LCD from number 1, which was new, put it on board 5, which was the junker after we fixed that bad pad. And we've got one good unit, and now circuit board from number 1 is now our parts board. Here we have our board number 1, which is now our parts board. This had a suspected bad display driver chip 2. And as you can see, I have removed display driver chip 3. And to remove that, I used a special type of handle for my rework station. You can see it looks like a desoldering handle, but it's got this funny tip here. So, the bad part about these is you have to get one for each size chip you want to remove, and it's got this little suction cup in the middle. So you put it down over the chip. Of course, this is off in room temperature. The suction cup goes up against the chip. You let it heat up. You press the button, turns on the vacuum, and then you can pull the chip up. So, works quite well. I've not used this a lot because I only have a few of these adapters for different size chips. I need to scour eBay for some more every once in a while. You can get a good deal. So I thought I would show you that process if I can. Now this is display driver chip 1 here. It goes 1, 2, and 3. And you won't be able to see it, but I marked an X on it. This is board 4, which is the alignment computer board, which worked, but it had some incorrect things on, which all seem to be related to display driver chip 1. So hence that's why we are going to swap it out and see if that takes care of the problem. All 3 of these chips are the same, so it doesn't really matter which you pull it from on the donor board as long as you have a good chip. So I'll get set up to do this and we'll see how it's done. I have removed the LCD from here since we're going to be soldering right on the back of it. We do not want to overheat the back of the LCD. Taken some flux from the can here, smeared it around the chip. I have my irons set to about 300 degrees Celsius, which is a little cooler than I normally run it, but for this old phenolic board, you need a little cooler temperature. And now I'm just going to take some solder and go along all the pins. Doesn't matter if we short out pins, get too much on at this point. We're preheating the board a little bit and adding a little fresh solder to make the desoldering process easier. Okay. Now I'm going to be blocking the shot here, but what I'm doing is placing this right down on top of the chip and trying to watch it melt, and then press the button to suck it up to that vacuum tip. Ah, darn it, I gotta lift the top board up to keep from melting things. Okay. Didn't get it that time. Gonna have to add some more solder around to make a better heat conduction path, I think. Chip got moved a little sideways. There we go. That was the trick, just adding a little extra solder on there to make a good heat conduction path. Now I'm going to take some solder braid and clean this off of here and then solder on the new chip, but I'm going to get this camera out of my face so I can do a good job at that. Okie doke, we got a new #1 display driver chip soldered in, which was donated from board 1 onto board 4 here. And I reinstalled the LCD. And I've got the hot wire leads hooked up so we can power with the bench power supply. Now we'll turn this on and see if we still have our phantom dots and stuff. Turn it on. And we do. It is exactly the same. That is strange. I wonder if this could be a failure in... Oops, you can't see that. That's exactly the same with that display driver changed. So I wonder if this can be a failure in the new LCD itself. That is a possibility. Or it could be that CPU 2, which is right here, that's what sends the data to the display drivers to be displayed. It could be bad, but I'm not sure that it would cause this ghosting we see. So I guess the easiest thing to try is a different LCD, since this frame has been bent and unbent so many times. Can probably still get away with it. And I've got some new LCDs, so we can try that, see if that works. If that doesn't work, then I'm thinking that it has to be with this guy, and I don't know that I have a good one. I could swap it out of board 4. Of course, maybe all the dark blocks in the middle, the LCD was from CPU 2 as well. I don't know. So let's try swapping the LCD since that's the easiest to do. And we'll see what that does. Remove the LCD that was in it. Installed a new LCD. Got it hooked up to the bench supply. Turn it on. And look, it works. We can reset it. Everything that should be on is on. And if I carefully make some key presses here, everything seems to work just as it should. Oh, crap, we've got a missing stripe right there. Okay, we just need to clamp that a little more. That's not a big deal. Okay. So I will fiddle with clamping this frame down a little more and continue testing. But that's something. I would not have guessed that the new LCD was bad. But anything can happen. Well, I wound up not needing to take the LCD frame off again. I got to thinking as I started doing that, hey, I just soldered that chip in there and I run my fingers along all the pins on the chip and the two stripes that were missing would come back and go missing again. So I depowered it, reflowed just those pins. I didn't bother taking the LCD off since I could do that really quick and easy without putting a lot of heat into it, and it works fine now. So we have repaired unit number 4 with a new LCD to replace the faulty new LCD. And the units we have left are 3 and 2. 3 works, but it has the original LCD, which isn't that great, so I'm still not sure if I want to change the LCD to that. And unit number 2 has a new LCD, but it's got a garbled display and it doesn't boot up. So I think we'll look at that one next. As for number 4 here, it's quite a dirty unit. It needs a good bath. I did another one similar to this as far as dirtiness. I called the Pigpen. The link to that is below. Well, you might think we were done with number 4. I contacted the guy that gave me this computer and told him that I had to replace the new LCD with another new LCD, and that took care of the problem. And he said, great. I think there was a problem with some of the keys. I seem to remember trying to type save and it didn't work right. So I took it apart again and I looked at the circuit board and it looked fine. I looked at the schematic. None of these keys have anything in common. So it's not like there's going to be a broken trace which is causing the problem. And then I noticed that the area around one of these switches looked kind of dull, and lo and behold, there were little tiny pieces of cellophane tape over these 4 key switches that they did not want you to use for some reason. And getting 30 or 40-year-old tape off a circuit board is an interesting experience, but got it off of there and it does indeed work. Well, this video is already getting pretty long. Even though these are little computers, they take a long time to fix. We got number 1 fixed, which was the most important because this belongs to a friend. I've had it for months and months. When I get it back to him, this is number 1. We swapped the guts of number 5 into it and swapped over the LCD from the original number 1 board and the positive battery lead, which has the diode in it. And I put a sticker on the back saying you can use 1.5 volt LR44 cells. So I'm going to get that back to him tomorrow. Also fixed number 4. This was the MMS alignment computer. You can see I've cleaned it up now. The replacement LCD that was in it was bad. That was kind of weird. Put another LCD in it, another new one from the same guy, and it works. So I put in loads of these. I've never had a bad one. Never heard of having a bad one. So it can always happen though. And then we had that problem with the tape on the key contacts, which is just plain evil. But anyhow, they made this for a specific product back in the day. So that's what they needed to do. Hopefully we'll be able to find some more information on this. It cleaned up pretty well. I could not get the badge here completely clean because it was starting to wipe off the print. But it's a lot better and it's not so dirty that you mind have it in your hand. Put the diode in the positive lead, added a sticker to this one as well. I had forgot about the keys not working, and I contacted the guy that gave this to me, and he was like, oh great, he was glad to hear that it was the LCD that was causing the weird problem. And he said, but I think there were some keys on that not working. And he said it seemed to him that it was something when you try to type save, some of the keys weren't working. And indeed, I went and checked it, and there was 4 of them not working. Anyhow, I already told you this. And then when I was putting it back in its slipcase, there was something down on the bottom, and it was this note he sent, which was printed on a PC-2 with the 4-color printer that he just installed gears in, which I thought was pretty cool. So I dug that out, and I'll slip that in the case with it. It's part of its history now. So we'll come back and we'll get started on number 2, which is going to be an interesting one. I won't go into details now. I've looked at it some, and I'm not sure which way to go, and I don't want to just swap out a bunch of parts randomly without putting some thought into it. So I can kind of put that on the back burner and think about it some more, and I've got more stuff waiting here on the bench to repair. So we might do 1 or 2 other videos before we get back to the second part of this one. Questions or comments, leave them down in the comment section. I would love to hear from you. Thanks to everyone who helps support the Hey Birt channel through Patreon and other means. There's information about that in the description if you're interested. And until next time, bye.